here's homework number 3 about solving systems by substitution, which is my favorite way to solve systems. So I'm very excited. And you should have already tried the problems on your own. And then while I work through them, you should check your work and make any corrections if you have errors. So on number 1, we need to substitute, hence the name substitution, one equation into the other. The equation that I'm going to use to plug in is whichever one has a variable alone is equal to a bunch of other stuff. So that is my top equation. X equals, so x is alone, it's equal to a bunch of other stuff. So wherever there is an x, I can replace the x with -1 plus 2y. So I'm going to plug that in right there into the second equation where there is an x. So my equation now is 2 times, instead of x, I'm going to put -1 plus 2y plus 3y equals 19, which is the rest of the second equation. Now I'm going to solve it algebraically, just like a multi-step equation that you've learned in Algebra 1 and again in Algebra 2. The first step when I'm following PEMDAS is to multiply or distribute. So 2 times -1 is -2, plus 2 times 2y is 4y, plus 3y equals 19. Next, I'm going to combine my like terms. 4y and 3y makes 7y, and bring down the rest of the equation around it. -2 plus 7y equals 19. Then I need to get my y alone, so I'm going to subtract, this is a -2. So I'm going to do the opposite and add 2 to both sides of the equal sign. -2 and a +2 cancel, so 7y equals 19 plus 2 is 21. Finally, to get y alone, 7 times y, do the opposite and divide both sides by 7. So y equals 3. Now I have y, and I need to figure out what x equals. So I'm going to take what y equals and plug it into my original equation that was x equals -1 plus 2. And instead of the y, I'm going to use what y equals, which is a 3. So 2 times 3. Now I'm going to simplify. X equals -1 plus 2 times 3 is 6. And -1 plus 6 is 5. Now, when I write my final answer, I should write it as an ordered pair. So my solution to the system of equations is 5, 3. Now, let's move on to number 2. Number 2, I need to pick the equation that has a variable alone on one side. So I have y equals, y is alone. So that means that 3 minus 5x can be written anywhere there's a y in the other equation. So I'm going to plug it in for y and rewrite. So I have 3x minus 2 times, instead of y, I'm going to write 3 minus 5x, and it is equal to 7. Now when I distribute, just like before, I distribute the 2, but it's not just a 2, it's a -2. So I have to distribute -2 to the parentheses. So it's -2 is being distributed to the 3 and the -5x. So -2 times 3 is -6, and -2 times -5x gives me a plus 10x. equals 7, and I have to bring down the 3x. It didn't go away. Now I combine like terms and solve for the only variable that's left. 3x and a positive 10x makes 13x minus 6 equals 7. I need to get the 13x alone, so the opposite of minus 6 or subtracting 6 is to add 6. 13x equals 13. 13 times x, I get rid of it by dividing by 13, and therefore x equals 1. Now that I know what one variable equals, it's easy for me to plug it back into the second equation and solve. The equation that I used originally was y equals 3 minus 5x. But now instead of an x, I know that x is the same as 1. So I'm going to substitute x for 1. Y equals 3 minus 5 times 1. 5 times 1 means y equals 3 minus 5. And 3 minus 5 tells me that y equals negative 2. Therefore, the solution to the system of equations is 1, negative 2. My third problem, I have y equals 4x minus 1 and y equals 2x plus 3. I can pick whichever equation I want to plug into the other, since I have y alone on one side of both equations. I like to just pick the top and plug it into the bottom. So I'm going to do I just made a mistake. I'm not plugging 4x minus 1 in for x, I'm plugging it in for y. So instead of y, I have 4x minus 1. So 4x minus 1 equals the rest of the equation, 2x plus 3. Now, I can't combine like terms the same way as in number 1 and number 2 because my x's are on different sides of the equal sign. So in order to get the x's on the same side, I'm going to move the smaller amount. To move a positive 2x to the other side of the equal sign, I have to do the opposite and subtract. So I'm going to subtract like terms. 2x and negative 2x cancel. 4x minus 2x is 2x. So 2x minus 1 equals the 3 that's left over. Now to get 2x alone, I'm going to add 1 to both sides. 2x equals 4 and divide by 2, so x equals 2. I take that amount and I plug it back into the original equation that I used. The original equation was y equals 4x minus 1, so that's where I'm going to plug in my value for x. Y equals 4 times 2 minus 1, 4 times 2 is 8 minus 1, so y equals 7. And so my solution to the system of equations is 2, 7. Now, my last problem for the homework, I have two equations, 3m minus 5n equals 2, and m equals negative 4 plus 4n. Since m is alone in the second equation, I'm going to take negative 4 plus 4n and plug it in for m because it is equal to m. So 3 times, instead of the m, I have negative 4 plus 4n minus 5n equals 2. I now need to distribute. My 3 times negative 4 is negative 12, plus 3 times 4n is 12n, minus 5n equals 2. I'm going to combine my like terms, so negative 12. Since 12n and minus 5n are on the same side of the equal sign, I just get to do that math. 12 minus 5 leaves me with 7n equals 2. To get 7n alone, I add 12. 7n equals 14. To get n alone, divide away the 7, and n equals 2. I need to now find out what my other variable is, the m. So I have m equals -4 plus 4n. That's my original equation. And I'm going to plug my value for n into it to solve for m. m equals -4 plus 4 times 2. So m equals -4 plus 4 times 2 is 8. m equals -4 plus 8 is +4. So my solution is, we're going to go alphabetically here, 4, 2. Last but not least, we have a challenge question here. My challenge question is a word problem, and therefore I need to write my system of equations and then solve it using substitution. So I have the sum of two numbers is 56. The larger number, x, is 12 more than 3 times the other. What are the two numbers? Now, remember that whatever it asks you is what you're looking for. So it's asking me what are the two numbers. In my equation, it told me that the larger number is x. So I'm going to keep that. X is my larger number. Therefore, I'm going to make y the smaller number, so that my variables are going to answer the question of what are the two numbers. One will be larger and one will be smaller. So when I look back at my word problem, the sum means to add, of the two numbers is 56. Is means equals. So I'm going to add the two numbers to equal 56. So my first number plus my second number equals 56. Now it tells me the larger number, x, is means equals, 12 more than means plus, 3 times the other. So the large number, x, means equals to, 12 more than is plus, 3 times the other number. My other number, since I already used x, is y, the smaller number. So 3 times y. Now my equation is set up very nicely for me to go ahead and do substitution, since I have x alone equals. I'm going to take my equation, 12 plus 3y is the same as x, and plug it into the first equation as x. So instead of x, I'm writing 12 plus 3y plus y equals 56. So this is my x, and it adds to y. Now I have no number in front or behind the parentheses without an addition sign, so there's no distributing. So I'm going to just drop the parentheses, 12 plus 3y plus y equals 56. Now I can combine like terms. Since 3y and y are on the same side of the equal sign, I can just add them. 12 plus 3y and y makes 4y equals 56. I need to get y alone. Subtract 12. So 4y equals 44. Oh, I'm sorry, came off the bottom of the page here. Divide by 4, and I get that y equals 11. My other original equation here, x plus y equals 56, is where I'm going to put my answer. Y is 11. X plus 11 equals 56. I need to get x alone, so I subtract 11. So x equals 45. So therefore my larger number, which is x equals my larger number, which equals 45, and y equals my smaller number, which is 11.